Hi guys. You have already had this introduction read to you, but in case you wanted to go back and re-listen to it at your own speed, I'm going to read this and then get to the next section and read that for you too if you'd like it to listen to it. Wherever chemical solutions are involved, pH matters. Some important chemical reactions, such as those involved in corrosion of iron or digestion of food, will only take place within a specific pH range. In agriculture, the soil's pH affects crop yields of fruits, vegetables, and grains such as wheat, barley, and corn. The control of pH is also important within your body. For example, the pH of your blood is maintained at a slightly basic level of approximately 7.4. In your stomach, an acidic pH between 2 and 4 helps you digest your food. The pH water in the environment is also important because it affects the survival of fish and other organisms. Scientists measure pH when they study acid rain and when they work to maintain drinking water quality. On to the next page. On this, as you read this section, you should be working on that worksheet 47.1. That's what that first direction tells you. And the first section of the reading is about the pH scale. As you observed in the last activity, the pH of a solution is a number that expresses how acidic or basic it is. The pH scale ranges from 0 for very acidic to 14 for very basic. At the middle of the scale, 7 is a neutral liquid, such as distilled water. The scale is not linear with equal increments like a ruler or a thermometer. The pH scale is a lot like a Richter scale used to measure the strength of earthquakes. An 8.0 earthquake is 10 times stronger than a 7.0 earthquake, and a pH of 3 is 10 times more acidic than a pH of 4. For every increase or decrease in pH of 1.0 unit, the acidity or basicity of a solution changes tenfold. Another word for that is exponential growth. You can see from the chart here the different items on the pH scale and where they range. We've talked about all of those before. On to the next page, must be C88. The color change of a pH indicator results from a chemical reaction between the indicator and the acid or base dissolved in water. An acidic solution contains acid and turns pH paper deep orange or red. A basic solution contains a base and turns pH paper blue or violet. Acids are recognizable by their sour taste and because they can dissolve some metals. Bases, from soap to bleach to drain cleaner, have other properties. They tend not to react with metals and are bitter in taste. They are slippery to the touch because they react with your skin oils to form a substance a lot like soap. However, both acids and bases can be corrosive to human skin if the pH is below 2 or above 12. The next section is entitled Acids, Bases, pH, and Industry. Controlling pH is important in the production of foods, paper products, and chemicals. The low pH of vinegar preserves foods, such as pickles, because it slows the growth of bacteria and other microbes. Because they are chemically reactive, acids and bases are also important in the manufacture of many products. For example, sulfuric acid is by far the largest single product of the chemical industry and is used to make fertilizer, refined petroleum, and clean and processed metals. Nitric acid is used to make explosives and dyes. The bases, sodium hydroxide and potassium hydroxide, are used to make soaps. Sodium hydroxide is also the main ingredient in drain cleaners. Ammonia, a base that contains nitrogen, is used both as a fertilizer and to produce other fertilizers. Remember to push pause anytime you want to stop and record something from this to put on that worksheet. You can see some of the things that were talked about on the last page. pH in the environment is the next section. If the pH of water in rivers and streams and lakes becomes too high or too low, many animals and plants cannot survive. Wastes released by human activity may disturb the acid-base balance in bodies of water. Even a small change from the normal range can harm some aquatic life and cause changes in ecosystems that are hard to predict. Most organisms that live in freshwater are healthiest at pH values from 6 to 9. Variations in pH outside of this range reduce populations of organisms by decreasing survival of adults and reducing reproductive rates. The next section is called pH in drinking water. The federal government's standards for drinking water require a pH between 6.5 and 8.5. Acidic or basic tap water may react chemically with water pipes and release contaminants into the drinking water. The biggest hazard is that acid may dissolve lead out of the metal of some pipes into the water flowing through them. Lead can have serious health effects that vary with dosage and among different individuals. Young children are much more sensitive than adults, but adults can also be affected. Lead acts on the brain, nervous system, and other organs, causing effects from behavioral and learning problems to seizures and even death. And there are the analysis questions that ultimately you will have to do according to what your teacher asks you to do. Like I said, use that reading as you wish. Go back, re-listen. Just thought I'd do that to see how it went for you. So, have a good day. Bye.